So, hello everyone. Thanks for joining us today. I'm very happy to have David here with me today. Um, just a, we will be starting in a couple of minutes just to give some additional time to any late joiners. Please feel free to let us know where you're joining us from, and we will be starting in the next couple of minutes or two. All right, I think we can start. So thanks again for joining us today on this webinar around event streaming platforms and 4 ways to think like a software architect when evaluating streaming solutions. I'm very happy to have David Esposito, our VP of Customer Engagement at Aiven, with us, and we will be talking about what are the considerations that you need to make when evaluating streaming solutions. So please feel free to ask your questions in the questions area, and we'll be able to reply to those on the Q&A at the end of the presentation. Some practicalities on the webinar. For a better experience, be sure to have some high bandwidth Wi-Fi or hardwire your device. You will be unmuted, but you're encouraged at any point to let us know where you're joining us from, where any questions that you might have. As we mentioned, the session is being recorded, and we will share the recording of the webinar after the webinar's end over email. And please share your feedback with us. There will be a short survey at the end of the presentation so we can keep improving and continue improving our sessions moving forward. So again, thank you, David, for joining us today, and I'll leave it up to you.
Perfect. Thank you very much. Let's see, I'll end up getting control of the slides in a second, and then there we go. So yeah, if everybody wouldn't mind, if you can share in the chat where you're from, maybe what your role is, what company you work for. I can tweak content a little bit or use examples from your industry. That would help me out a lot, if you don't mind. But to set the stage a little bit, event streaming platforms wanted to make sure we're level set, understanding what that means, because a lot of people have a lot of different opinions. So what I'm talking about today is any infrastructure or technologies that event-driven applications are going to run on top of or integrate with in some way. So this, when data is sitting in a database as a row and it's sitting at rest, there's certain value that is provided to the application and to the user. But as we move towards mobile applications, as we move towards real-time interactions for users across the application in collaboration, you want to see data in motion. How do we accomplish that? Event-driven architectures and event streaming platforms, specifically the infrastructure that runs on top of. So this is going to cover a couple different perspectives from do you run it yourself with a do-it-yourself solution running on bare metal or a VM somewhere in the cloud, or do you go all the way up to abstracted technologies of publish an event and magically stuff and insights flow out of it. So we'll talk about that different range. And the goal today is, as you'll see, it's not to tell you which technology to use, but it's going to give you insights on how to evaluate the different platforms, compare them, and understand the risk and complexity and return on investment that you might get from different technologies. So that's a level set what event streaming means to us and sort of what I want to accomplish today. So we'll move into what it means to be a software architect. So a software architect is someone that has deep technical domain expertise that may be at the application level, it may be at the industry level, maybe at infrastructure level, or it may just be based on experience in the past. You're able to use previous experience and failures or successes to influence how you solve problems in the future. But an architect differentiates themselves from a developer in that they have an unconventional curiosity about how things interact. So I'll talk about the different levels that we'll dive into, but from a developer perspective, you're laser focused on solving individual problems and writing code. You can become more senior or even principal or distinguished level to solve bigger and bigger problems and influence larger teams of developers. But once you start going down the architect path, you're now stepping back and understanding how does this decision or this change or this error affect other things. And you can zoom out in that domain perspective of looking at how does it affect this one application, how does it affect a team, how does it affect an entire department, or all the way back out, how does it start affecting the entire company or even the industry that you're operating in. So we'll talk about all those different levels, but that's sort of where I wanted to start with defining software architect. So an expert that is curious about how things interact or break each other. We'll talk about that later. So a little bit about me is I'm a recovering over-engineeringer, if that's a word. Oops. I have a background in streaming IT automation. I was a full stack developer years ago. My latest tech stack was enterprise Java and React Redux applications. So not too long ago, React was a popular thing. But most recently worked on a large scale deployment for streaming IT automation. So I understand running at scale in event-driven applications. We did about 4 billion events per day, which is starting to measure events per millisecond, which is a very different challenge than measuring events per second. And then we were running about 2,300 Kubernetes pods in production and had a couple other non-prod environments as well. There as application, platform, enterprise architect type responsibilities of that company. Coming to Aiven, got a chance to talk to lots of different people about lots of different problems with different requirements from a load perspective, but also from a severity or impact perspective. So it's very interesting talking to say e-commerce companies versus talking to security or healthcare or financial services, the different concerns that they have. So I've learned a lot about how technical leaders think about their business and their technologies. And then for fun, I worked with a professional blackjack card counter to build the biggest blackjack simulation in the world. We simulated about 13 trillion hands of blackjack, peaking at about 2.4 billion hands per second. It was a lot of fun, but actually pretty proud of my, I used a streaming fan out architecture and actually maxed out without requesting upgrades, but maxed out the quotas for AWS Lambda in one of the regions. So maxed it out for a couple hours, and I'm sure some people got a few alerts. Nothing broke though, so congratulations to the scalability of AWS Lambda. Appreciate it. So let's talk about what all of that experience and knowledge, why am I here talking about that today? I want to dive a little bit more into what it means to be an architect and think like an architect. So, I said before, an unconventional curiosity. I honestly think that a lot of developers or executives will look at an architect and think they have all the answers. I go ask them a question, I get what I need. I think as you work with more architects, you will realize that they will ask more questions than they give answers, which is exactly what you want. Based on previous failure or previous successes, they know the nuances of situations and what to ask. So an architect is not about having answers, it's about knowing what questions to ask. wisdom is just a really nice word for where you have experienced failure or success. So where we go from here. Wanted to dive into a couple different topics, and we'll zoom out from a lens. You see ripples will expand. So we'll start very technical, talk about downtime. What are the considerations and impacts that a platform or shared responsibility model might have on your end customer experience? So when an error happens, what do we do? When a service is down, what happens? There's certain questions that you need to think about, and I'll talk about general applications as well as deep dive into specific streaming insights. Then we'll zoom out a little bit more, talk about team impact. This is still fairly technical. So when you make a platform or technology decision, how's that going to impact how you hire the team, staff the team, train up the team? And then zoom out a little bit more, think about integrations. So now it's not just the team, but we're going to talk about departments. So when you make a decision, how's that going to affect engineering and DevOps and operations and support? And so we'll look at that higher level and then zoom way out and start thinking about, and this is where chief architects and enterprise architects spend a lot of their time, is understanding the customer growth patterns, customer use cases. How is that going to scale in the industry? And what does that mean for your internal departments and the company profitability? So understanding those scaling ratios and scaling mechanisms. So let's dive in. Thinking about downtime, it's really important to understand that the cloud is going to be the cloud. They are servers living somewhere, and they have redundancy built around them. But at the end of the day, it's a box that's plugged into a wall, sitting in a rack somewhere in a really cold room. So the answer is not when, if failure is going to happen, when failure happens. So when your database rolls over because of an update, or they're moving racks around and unplug or power cycle your rack because of failed disks, it's not if it's going to happen, it's when. And this clearly laid out in, I'll jump around a little bit on the bullet points, but if you read the fine print of the uptime SLAs, so go to a cloud provider, for example, let's look at databases or streaming platforms. Let's read the service level agreement, read the fine details, especially on exceptions, because they may claim to have some amount of uptime. So maybe it's number of nines, 99.9% uptime, or maybe it's 4 nines of 99.99 or 5 nines. But what that's really going to mean is that at the end of the day, 3 nines is going to be a little under an hour of downtime per month is allowable, not guaranteed to happen, but is allowable. And then when you go to 4 or 5 nines, so 99.999 amount of uptime, and that's usually you see in regulated industries like healthcare, some IoT, but where lives are on the line, maybe money. 5 nines is about 5 minutes per year. So that's they're contractually agreeing to less than 30 seconds per month. But I say read the fine print, because a lot of times when you go look at that, maintenance windows are excluded from the uptime SLA. So they guarantee that you're only going to have 5 minutes or 50 minutes of downtime per year, less than 10 minutes per month. But maintenance windows are excluded. So, all right, I'm going to go look at that. Maintenance is expected to have up to 10 minutes of downtime based on standard operations. You really want to understand the fine print, what's excluded, how's that going to impact. But that goes back to the first bullet point of contractual versus observed. So they will do a good job defining, letting you know upfront what's included, what's not included in that uptime calculation, and they will contractually agree to providing a service. If they exceed, great, everybody's happy, including them, I promise. I'm on that side of the table. But if they fail, the observed uptime may actually be less than the contractual. And that's where you really run into problems of understanding what their policy is for observed SLAs that are lower than the contractual. different companies have different policies. Sometimes they're happy to invest engineering resources to fix technical debt and instability. Sometimes they're happy to provide you credits and say, good luck, we'll try not to do it again. So read the fine print, understand what goes into the SLAs, and understand the policies of the company, how much they invest into fixing any issues with that. And then the other point on downtime is the when, not if, as have a disaster recovery plan. When things break, what are you going to do? And this goes into defining not only defining the disaster recovery plan, documenting it, but a recovery time objective. So how fast are things going to happen? When there's a complete outage, what is the user experience, and when do you expect service to come back online, or even just degraded service? When are they going to be able to access your platform again to get some usage? Is it phased? Is it cutover? Is it failover? So here, as you start defining this, you'll start getting into multi-AZ discussions, multi-region discussions, or even multi-cloud. If you're really trying to get 5 nines maximum uptime for critical cases, you're going to get into much more complex deployments. And there's a certain level of investment that goes into higher uptime. So be honest with yourself what the end user experience should be and how much you want to invest. And then my provocative point that I always like to call out with downtime planning is it's great to have a disaster recovery plan, but if you have not tried it out, if you have not run that, you can't do it. You should have zero confidence in that plan will actually work if you've not just sort of tested it in a test environment, but actually run through it with all of the appropriate parties involved, coordinating. And it may be a war room day, it may be a production upgrade exercise where you actually go through this type of exercise. But if you have not run it, you can't do it. And can't as in not allowed, but can't as in assume you're not able to complete that plan. A little provocative, but I do like to call that out because the unexpected always happens. So how do those high-level industry general insights apply to event streaming? For streaming applications, producers, the things that come up with the events that are going to push them somewhere, if they can't connect to infrastructure because of connectivity issues or downtime or even bugs in the code, what happens to the data? Does it get dropped there? Do you cache it? What happens if it's living on a Kubernetes pod, which is going to give a bad health check and kind of roll over and replace itself? Is that going to result in data loss if you can't publish it? And are you okay with data loss? So understanding failure cases and being having a solid plan for how you're going to carry that out. The second one is picking the technology. This is more so which application or infrastructure you're using, but idempotency and ordering is make sure that you understand the cases where events can be processed multiple times, as well as how it's going to be handled and partitioned or fanned out across your consumer applications. So understanding how they're going to be delivered is very important to your application architecture. So pick the right technologies to meet your use case, but then also understand the SLAs, how often you could be in those failure states, and how okay you are with out of order events or duplicate events being processed or data loss. And then isolating workloads is going to be for much more mature companies. Aiven is a company that sells managed Kafka. We see lots of customers or prospects that start with a small cluster and grow until they're hitting tens of thousands, hundreds of thousands, millions of events per second, and get to the point where, hey, this ETL job is flooding these X number of brokers and actually causing downtime or outage on critical customer-facing or like billing systems. So understand which workloads are important, how they can affect each other, and there are some technologies which help isolate those for you. but there are some cases where you're responsible for understanding that. So those are the downtime considerations. So we zoom out a little bit, we'll talk about what the team implications are and how you can better equip yourself to handle those. So we'll talk about how do you earn money, and that's a very backwards way of getting back to a very technical challenge that architects need to ask questions about and help solve. But how do you earn money is a provocative question that I like to ask customers or prospects, especially if they're running do-it-yourself technologies. If you're running Kafka yourself or databases yourself, do you earn money by being really good at running infrastructure, or do you earn money by providing value to your end users, your customers in a different way? Where and how do you want to invest those resources is going to be really important to how fast you can deliver value to your end users. So shared responsibility is the first topic to dive into, because if you're running infrastructure yourself, you're going to be responsible for not only operations, but also reliability engineering, as well as application development. And you're going to have a lot of broad expertise across all of those teams. It's going to change how you structure and build your teams to have the right amount of expertise. So you really need to understand, if you're leveraging a vendor or building on top of a platform, what is it expected that they do and what's expected that you do. Make sure that, to the last point, you have the right amount of expertise in the equation. If you don't have Kafka experts or PubSub experts or Kinesis experts on staff, do you have the right partners or the right support plan? Or do you have the right hiring plans to ensure that you can be successful in whatever equation that you set up? So get the right amount of expertise involved, and make sure you understand who's responsible for metrics monitoring, for scalability, for cost reductions, for application architecture, for query optimization, for broad range. Where is the line drawn of this is your problem, application side, or this is the partner or managed vendors problem on the managed service provider side. In the lost opportunity cost, again, if you are responsible, for example, for operations or reliability, then there are cases where you are acting very tactically against spikes in load or alerts going off from your monitoring solution or patching servers and running maintenance. That may be lost opportunity cost of you're not able to deliver value to your end users. So again, how do you earn money? How can you do more of that to earn more money? And then calculate that cost, make sure there's some return on investment, offload the work of where you don't earn money to someone else so that you can focus on the high impact tasks. So don't lose developer cycles to operations tasks if you don't have to. So how does this specifically apply to streaming? These are a few interesting ratios that I've found to be a lot of pain in engineering departments throughout my career, talking to companies as well as working in them, is the Alice and Bob versus Stack Overflow ratio. How many questions or error messages that come up can be solved by Stack Overflow searching the internet, or how many have to go to Alice and Bob who sit in the corner and built it 6 years ago? I think if you can answer this question, then that's going to greatly influence when you bring in new team members, how fast can they deliver technology? So make sure that you understand the ecosystem score around the technology. And this GitHub of T function is going to be search a technology on GitHub, Kafka, Postgres, Kinesis, for example, and see how many GitHub repositories are related to that technology. How many developers are committing to those or have it in their profiles. I think if you can understand the breadth of the ecosystem, you get a better idea of how easy will it be to hire for this talent, or do I need to hire and level up? And then a build versus buy solution. It'll be important to understand what investment you need to make this technology or this platform work with your application stack or your current setup. So those are going to be the streaming level insights for how it impacts your team. Again, this is low level. How's it impacting your development teams? Next, we'll zoom out again to department wide, engineering, operations, DevOps. But I did want to pause. I talk a lot and quickly, I know. So wanted to pause and see, are there any questions that anybody has up to this point, or any insights that you can provide to the conversation? So I'll pause real quick and tell a joke. Well, we'll see if any come in. How do you catch a rabbit? You lay in the middle of a field and make carrot noises. Good. Marcos, I'm not seeing any questions coming in, or any on your side.
No questions that I can see on my side either. Actually, there is one. Yes. So regarding migrating from existing solution to a new one, based on your experience, what are some realistic timelines for the migration, and what costs should we consider when going through that migration? Maybe something to reply to now, or something that we'll cover later.
Yeah, absolutely. That's actually fits right in with both the topics I just covered. So if you think about, you guys, timelines as well as complexity or cost, think about the first thing I talked about, downtime. Are you okay with cutovers that could be extended and dealing with some downtime during the migration, or does it need to be a live migration? With streaming technologies, usually it's a lot easier to set up a live migration because you're essentially either dual writing to both systems, or maybe there's technologies in the ecosystem like Mirror Maker that can help replicate Kafka data from one region or one cluster to another. So downtime is an important consideration, and the less downtime you have, the more complex it is going to be to make sure that the cutover works is successful and you pick up where you left off, and you don't process duplicate data or have data loss. So timeline-wise, more of it's going to be on the planning side, especially if you want to minimize downtime. Complexity and cost is usually looking at any upgrades you want to make to the system from a security or reliability perspective. Understand, is this going to be a lift and shift over, or are you going to make a cut over to best practices? And this is a big conversation when you're moving on premises to the cloud. And I strongly encourage that if you're on premises, moving to the cloud, leverage cloud native best practices and go ahead and invest in those. So have a multi-AZ failover compliant application setup. So those improvements are going to be where the cost and complexity is. It's going to require developer time to understand how does the application perform if they can't connect to a certain AZ, or if there's additional latencies because they're connecting across data centers as opposed to sitting in the same rack as a Kafka service. Cool.
Perfect. Okay. Thank you.
Yeah, no problem. So I guess we'll go ahead and move on and have more time for questions at the end. Just want to make sure we take a little break instead of full steam ahead. So the next place where we zoom out is now we were talking about how do you impact, how are applications impacted by your decision. Then we talked about how are teams impacted by your decision. Now we zoom out a little bit more. How are technical departments impacted? How does this impact engineering, operations, DevOps? And this is where we want to talk about building on the shoulder of giants. Every org and team is going to have its own mission, what it wants to accomplish. So if you look at SRE and operations, they want to know telemetry and really understand what's going on, where the instability might happen, and how they can invest to improve that. So they're going to look for an ecosystem of tooling to support that. And if you pick a vendor or a platform that hooks into the tools you're already using, that's going to be much easier. If you don't, then you're going to have to build glue code around that, or build hacks to get, multi-hop to get metrics from one system to another, and transform it into your final Grafana dashboards or Datadog dashboards. So you want to pay attention to what is provided by the ecosystem and build on the shoulder of giants. Again, back to how do you earn money? Where do you want to invest your resources? So build versus buy. Do a return on investment calculation to understand, do we want to build this glue code to make it work? Or is there another possible solution that maybe the bottom line is a little more expensive per month, but it integrates with our existing tooling much easier? Pay attention to how you affect other departments and teams. A good place to have conversations about proprietary versus open source. Understand the how sticky some of those features or licenses might be. If you ever need the flexibility to move away, whether that's moving to another cloud, moving to another technology for technical or financial, commercial reasons, make sure you have a backup plan and a failover plan. There are places where you need the AI and ML and global distributed systems proprietary functionality out of the box. And there's cases where those are nice to haves, and you can work around not having that. Or you can build, Pareto's principle, 80-20. You can spend 20% of the effort to get to build 80% of the functionality on top of open source without having to lock yourself, vendor lock in to a solution that you're not going to be able to move away from. Understand the trade-offs there and how that's going to impact teams. And then want to make sure I call out, if you've never read RFC, the request for comments 2119 for web standards, it defines must, should, must not, it defines different terms. So when you see all caps in engineering, like MUST, must, that means something very specific, and that is defined in 2119. Go read it. It's less than 2 pages, maybe a page and a half. Very simple read, and you'll find other interesting RFCs that you didn't know about. But must, meaning that, from my opinion, there's no option. It's not should. There's not an option to not do it. If an application team or engineering department makes a decision without bringing in DevOps or security, or vice versa, it's going to create blindness for other teams, causing pain. So observability, make sure you engage with all of the stakeholders to understand what information do you need out of the system, what problems or challenges are you going to have with it, so that you can set all of the teams up for success with that. Observability is a must, whether it's API monitoring for metrics, whether it's logging and SIM solutions for security, or if it's traceability from an application perspective to understand latencies and user experiences. Make sure that observability is built in and planned from the front. So what's that mean for streaming? The streaming applications that I've seen, make sure that the technologies that you use for deployments and automation integrate with that platform or that technology. So if it's a do-it-yourself, you're deploying, managing Kafka, RabbitMQ by yourself, can you do it with Chef, Terraform, Puppet, Ansible? Pick your technology of choice. If you're deploying on a platform or a managed service provider, make sure that if you're running a Kubernetes, do they have Helm charts or a Kubernetes operator? If you're running a Terraform, do they have a provider? Do they have maybe even CLI tooling so that you can write your own bash scripts to do whatever you need? Make sure that you account for what is going to be required to deploy it repeatably and reliably, to make sure that, especially for disaster recovery plans. Security and governance is another big thing as your application is going to, as your application use case and your company grows, streaming data is actually where a lot of your company's IP and value that they're going to provide to the customers and users comes from. So data in motion is extremely valuable. What can you do? One, to make sure that it's secure and not leaked externally, but two, governance. How do you identify, document, and share that information across teams so that you fully enable your organization to leverage, whether it's streaming data or data at rest, in a BI or an insights tooling. Make sure that the platform you pick fits into your security posture, as well as fits into your governance philosophy. Observability, I talked about, and the testing is going to be very important from an application perspective. Do not overlook quality. Understand what testing frameworks, harnesses, tooling is built on top of it from a unit testing perspective. So little bits of code, making sure everything works, all the way through end-to-end testing. Understand how observability helps with testing streaming applications. And if you don't have observability or testing tooling in place, you will very quickly discover how painful it is to click a button over here and then expect for it to make 19 hops across microservices and then not land in a database somewhere. You'll very quickly see the need for number 3 and 4. So make sure you invest there. And the last but not least, we'll zoom out even further to past affecting multiple teams. And we'll start looking at total cost of ownership. How do you affect the company that you're working in, making sure that you have a viable scaling solution, as well as maybe even start raising the bar, pushing the limits in the industry that you work in. For streaming especially, predictability is going to be extremely important. And if you've been running cloud workloads for a while, if you've ever looked at a cloud bill, you will know, and this is not a secret to most technical leaders, the most expensive part of the cloud is between the keyboard and the chair. So your sprint teams, honestly, are going to be much more expensive than any cloud infrastructure that you're running. There are certain cases where you may scale and have a great scalable architecture and get past that limit. But for the most part, if you let costs run away in the cloud and don't know where or how you're spending your money, it's going to run away very quickly. And it's not going to scale with how you want to scale. So make sure that you're not only looking at where you're spending your money, but you're also paying attention to sprint teams and enabling them to be fully effective and deliver value where they need to deliver value. They're not distracted doing operations or tactical work when they're expected to be doing development work. Make sure you have a line item for everything. This is often overlooked. I go look and see that the cost of a server is X, but then I don't understand what are my usage patterns going to be for cross AZ Kafka deployments, or when I'm streaming an IoT solution from East Coast to West Coast for a smart car application or an IoT home security application. Understand networking and egress costs, understand the tooling costs associated with it, and then back to the point about having enough expertise in the equation. Understand if I pick this technology or this platform, what other investments do I need to make to ensure success, that I have enough expertise. And that may be the professional services part. Depending on your cloud spend, go ask if you can have free credits for Google or AWS or Microsoft to pay for some expertise to set you up for success. But the big point that I want to talk about here is billing patterns and how that scales with growth. And I think that's important for an architect, a technical person, to understand the trends in the industry as well as the implications on the larger business. So historically, and especially if you're still running on premises, subscription based billing has been the most popular, where you pay for access to some enterprise features. And it's usually annual commits, or maybe it's a multi-year contract, but you pay for access to some functionality. And then maybe that scales a little bit based on how many CPUs you're running or how many servers you're running. But it's essentially a licensing fee. As companies move to the cloud, they realize that it's much more profitable to take away the complexity of capacity planning and take away that cost savings mentality of subscription. How do I minimize CPUs? How do I minimize servers? And just move it to a simple usage-based. So there are usage-based streaming providers which will charge you per megabyte sent, or they'll charge you per message sent, or it may even be however many committed actions or duplicate actions that you take. It may be on an application operations level, but they'll take each of those units and then it gets multiplied out by some cost. And what you'll find is that works very well. You may spend $4 or $7 a month at the beginning when you're just getting started, but that scales extremely quickly. The answer to that is reserved infrastructure. So similar to subscription, you then become responsible for doing capacity planning yourself, understanding your workload and how much compute, whether CPU, memory, disk, is needed, and then you purchase plans or services that can meet those operational needs. So the pattern in general that we see, I will stay away from naming specific technologies, but you'll see that there's usually a startup growth path from startups, and small companies use usage-based pay per operation and move towards reserved infrastructure, where they're starting to deploy on Kubernetes and paying for some number of servers to run some number of pods. But price predictability is going to be much more predictable at reserved infrastructure. So as you grow, you definitely want to keep that in mind. So as we zoomed way out, if we backtrack, we look at an architect is not going to have the answers for what the right solution is. I can't tell you right now if usage-based is better than reserved infrastructure-based billing for your company. What I can tell you is the nuances of those decisions and what questions you should be asking to come up with the right solution. You zoom back to the company as a whole. How do you make sure you're profitable and viable? Back down to how are you affecting other departments and teams with the decisions you make? And then back down to how are you impacting the way that you staff and grow teams and technical talent, down to the very, very technical, what happens when things fail or there's errors. So again, this was not a presentation or webinar to teach you the right platform or tell you which one I recommend. There's many technologies and many vendors. Aiven is one of them that we'll tell you about a little bit later. But these are the questions and considerations and nuances that you should ask when evaluating streaming platforms. So I will pause here again. Are there any questions? It looks like I see one from Marcos in the chat.
Yes, there are a couple of questions. So a question from Alan. He mentions that streaming becomes very complex once you cross contexts. How do you minimize this effect or consequence? And is KSQL or equivalent tooling really a solution at scale?
Sorry, to make sure I heard it correctly, it becomes more complex once you cross context. So I'm guessing
Yes.
This means joining streams, whether it's between multiple microservices or even maybe pulling data from multiple systems. Yes, yep. It's going to become very complex, and even with technologies like KSQL, in my previous company, we used Flink, which is a similar event streaming that has a slightly different ecosystem to connect to multiple databases. There's some tooling that simplify it, but you have to realize that you're always going to run into race conditions and data consistency issues. with streaming applications. So I wish it was simple that events just flowed through from one pipe and came out the pipe at the other end. But there are joins, splits, forks. There's timing issues, network latencies. This is why the observability is really important from a tracing as well as a metrics and monitoring perspective to understand where those race conditions can happen. KSQL, KSQL and Flink and those technologies, from what I've seen, they're a great way to dig in at surface level exploration of the data to get a really good understanding of what's going, or get a high level understanding of what's going on in the system. But they become more difficult as you dig into complex production use cases or applications where one, you're joining multiple data sources, or you're dealing with order of operations, latency sensitive race conditions. It becomes much more complex the more that the tool is simplified. So for complex workloads, it's great to try them out with whatever tools make it simple and are available. But I've always found that building streaming applications is almost always going to be the end solution that you land on.
Right, thanks, David. Another question is about, so streaming seems to be bounded to cloud providers and does not extend easily outside of these. It is sometimes the case that you want to stream to client premises or apps, or like from SFTP onto S3 seems archaic, albeit effective, but streaming effectively stops or has a boundary. What are your thoughts on this?
Yes, I'm actually going to fork my answer a little bit because since you mentioned like SFTP to S3, you want to make sure that I handle the event-driven applications. So like click a button, or maybe a chat comes in on the server, and then how's that get propagated out to endpoints, and then separate that out from streaming like large data chunks, whether it's audio or video. I break those up as separate problems, and yes, reliable data streaming is much more difficult. From my perspective, there's technologies to help with that, but this type of infrastructure that I've been talking about today, how you evaluate it, I wouldn't always see Kafka, for example, as a great solution for that. But if we talk about streaming from a centralized and distributed computing environment, when you're talking about, there's obviously WebSocket technologies, but there may even be, if there's a centralized region that you're running in, you may want to stream out to on-premises data centers that are sitting in a warehouse somewhere or in a manufacturing plant. There's certain technologies that enable that, and it may be cloud specific, like AWS Outposts allows you to have a custom AWS region or availability zone. You put a rack somewhere, and then it gets linked into networking, and you can deploy. So there are solutions like that, as well as providers like Aiven is AWS Outpost enabled. You can deploy Aiven clusters to AWS Outpost if you want to run that type of solution. So you could run multiple Kafka clusters and replicate using Mirror Maker. Now, if instead you're talking about on-premises data centers, traditional data centers that you may have, and having a hybrid environment, private cloud, public cloud, or even in-house, like back of the closet data center that you're running to the cloud. It's a complex networking setup, usually direct interconnects, and there's additional costs associated there that we can do. You have to do total cost of ownership analysis over. But there are mechanisms and technologies that do help with streaming there. You can also mix and match technologies based on the ecosystem. So Kafka does have, you can have a central cluster which is running and then have network connectivity to endpoints distributed in other data centers, even on private networks. and have different technologies like MQTT running, or maybe you hook it up to S3 and have Kafka connect sources, which will pull events from different systems and stream it back into a centralized region. So yeah, without knowing more about the particular use case, there's lots of different ways to solve that problem, but they each have their own nuances and complexity associated.
Perfect. Thank you, David. For anyone else that has questions, the questions tab is still open, so feel free to put those in. We do have a couple more. One is about training costs, and specifically, they ask, should we include training costs and time spent to be trained and ramp up to the total cost of ownership for the solution?
Yes. So again, this is going to go back to the shared responsibility matrix. It's really important to understand where the vendor draws the line of this is your problem, we don't do that anymore, and where they say this is on us, or even somewhere in the middle where it's collaboration. So Aiven, for example, because I don't want to misspeak about any other providers or competitors, Aiven, for example, we draw the line at application and query layer. So we will anything that is application specific query optimization, anything that a DBA would help a developer with, is going to be on the customer side, and we do have a partner network that can help with that. So there could be associated cost, but from an observability and security perspective, we have shared responsibility. So on the availability, operations, performance side, Aiven obviously will monitor those solutions, but then the customer end user, the application would have to monitor its performance and connectivity, and then from a patching, upgrade, security, hardness, and improvements perspective, Aiven would be responsible there. So if you look at where those responsibilities fall, how much training needs to happen, there's some gray areas across the application line of if you have in-house expertise to understand how to do query optimization or streaming architecture patterns, then obviously that in-house expertise will help. Aiven does help from a consultative manner, but you need to pay attention to where professional services can come in. On the training and operations side, there's usually onboarding sessions, and different companies will handle it different ways. We invest in customer success up front, so we do everything we can to provide training material and sessions to get customers set up with everything they need to know when issues are happening, alerts configured, email alerts, status page updates, so that everything flows into the tooling that you're already using. So, long answer short, look at the responsibility matrix and understand where the expertise gaps are going to be, what the expectations are, and where you do need that training. It's going to depend on the provider itself, but that definitely needs to go into the total cost of ownership.
Great, thanks a lot, David. Just another question that's related to open source, I think that you mentioned earlier in the slides. So talking about open source, what is your thought about vulnerabilities and issues? How do we ensure that these are not impacting the SLA that we want to achieve, and how specific support of the solution or the service comes into play?
Yep. Yes, open source is a one that's Aiven's bread and butter, so it's very important to us. But if you're using an open source technology, you need to understand of where the expertise is going to lie and how fast that can be delivered on, within the managed service provider. So if you're talking to a vendor, do they have contributors to that project? If you're talking to a vendor, will they be able to deliver patched or 0-day pre-release builds to patch that security fix before full release candidate goes out for the open source project? Are any of the improvements committed upstream back to the project? And then finally, from a security perspective, how does the company know when those vulnerabilities happen? Is there someone at that vendor watching these security channels to understand vulnerabilities? And then how quickly does that go and get escalated to engineering and operations teams at the vendor to then patch vulnerable services? And that's, I think you'll find varying levels of answers depending on who you're talking to, whether it's a cloud provider, a vendor, or just a service-specific vendor, or a multi-service vendor. There's going to be different practices that are more or less mature across each of those. Get answers to those questions and understand how it impacts you, and really try to figure out at the end of the day, what is their investment back to the open source community? Are they in it for maximizing profit and minimizing investment? So go back to the observed versus contractual SLA. Are they going to give you credits and say, sorry, it was vulnerable, we patched it outside of the SLA and it was okay after a couple of days? Or are they going to over deliver and over invest in your success? I think one of the tenets Aiven has is giving back to the community. We actually have people on staff, a full open source contribution department with dedicated developers contributing back to all the technologies we offer. Some of those are up on screen right now. But again, if you want to try any of our platform out or try these services out, there's a free trial you can sign up for. Connect with me. I would love to jump on a call and talk about more interesting problems, but can also get you connected with my solutions architecture team or customer success or sales teams if there's specific business challenges that you want to solve. And then I think sometime soon, Marcus or my team's going to post an office hours link. You're more than welcome to set up some time with me to chat, even if it's just about a cool problem you have, or if you're an aspiring blackjack card counter and you want to know why I still have a day job and I'm not sitting in a casino counting cards.
Perfect. Thanks a lot, David, for replying to those questions. I'll keep it up for if there are any additional questions that the audience might want to ask. We have a couple more minutes left. And as David mentioned, there are some additional resources available posted on the chat right now. And as we also discussed earlier, we will be following up with the recording of the webinar over email, so you can refer back to it and listen to it at your own time.
Perfect. Yep. Thanks everybody for the time. Connect on LinkedIn. If you have other questions you want to ask in a public forum, point me somewhere. More than happy to engage and answer more questions in the open, or if you want to have a chat, let's talk. So appreciate the time. Thanks everybody.
Perfect. Thanks everyone.